This is a video tutorial on how to graph absolute value functions. I'm hoping you've already tried the first 2 pages of this packet. If you haven't done so, please stop the video and go back and try to do those 2 pages on your own first, and then continue to watch. So for an absolute value function, the parent function looks like f of x equals the absolute value of x. And if that f of x bothers you, remember that really just means y equals the absolute value of x. So we're graphing absolute value functions which have 2 variables here. It looks like a V shape. And it starts at the origin, so its vertex, the common endpoint, is 0, 0. And then it always goes up 1 and over 1. Remember, the more points you plot, the more accurate your absolute value graph is going to be. And I'm going to cheat. Oh, that was not that good. And make sure it goes all the way through the coordinate plane. And you have arrows at the end of it. Moving on to the next section. Let's look at what happens when you add or subtract a number on the outside of the absolute value. Well, that's going to take your absolute value function graph. It's going to move it up or down. If you add a number, it goes up. If you subtract a number, it goes down. And that should hopefully make sense to us. When we were dealing with y-intercepts on a linear equation, if we had a positive number, it shifted it up. If we had a negative intercept, it shifted it down. So we're used to this. So looking at f of x equals the absolute value of x minus 3, that minus 3 on the outside is going to take it and shift it down 3 spaces. So its new vertex would be 0, negative 3. So it's starting not at the origin, but 3 spaces down. And then it's still going to go up 1 and over 1 and up 1 and over 1. And the arrows were not working out too well for me, so I'm just going to freehand it here. You would hopefully have rulers, and yours would look a lot nicer than mine. So number on the outside moves it up or down. Next page. What happens when we add or subtract a number on the inside of the absolute value? Well, hopefully you realize from the graphs we did the other day that it moves it left or right. Now the problem here is it's kind of opposite of what we would normally think. On the inside, if we add a number, it's really going to the left, and if we subtract a number, it's really going to the right. So you have to remember that on the outside, it's normal. It does what you think it will do. But on the inside, it's opposite of what you would normally think. If we add a number, it goes left. If we subtract a number, it goes right. So if we're graphing f of x equals the absolute value of x minus 3, that minus 3 on the inside, that's really going to take it and shift it to the right. So its new vertex would be 3, 0. So that graph would start there. And notice we're still going up 1 over 1, up 1 over 1. The more points you draw, the more accurate it will be. And some of you might freak out a little bit because when you shift it left or right, suddenly it doesn't appear so symmetrical anymore. That's okay. Hopefully we can still see that's making that V shape. It just might appear that one side looks larger than the other one, just because this one's getting cut off a little bit. Next graph. What happens when we put a negative in front of the absolute value? Well, that took it and flipped it upside down. Mathematically, it's a reflection across the x-axis. Now our origin, notice nothing was added or subtracted at the end, nothing added or subtracted on the inside, so our origin is still 0, 0. But now instead of going up 1 and over 1, we're going to be going down 1 and over 1. Okay, and then we do the other side of it as well. Now we're connecting this way with arrows at the ends. Okay, what happens when we put a number bigger than 1 in front of the absolute value? Well, if you look at the examples we did the other day, it gets thinner or skinnier. And if we put a fraction in front of the absolute value, that's going to make it wider or fatter, depending on how you think about it. And if we look at number 5 and number 6 on our previous worksheets, okay, these are the two questions where we had a number or a fraction out in front. Okay, hopefully you looked at those and tried to figure out how you could quickly graph these without creating a table of values. Okay, that number out front of the absolute value is kind of like the slope. Okay, it's going to tell us from the origin, from the vertex, sometimes it's the origin, from the vertex though, how many we're going to go up and over, or down and over. So now using these things we discovered, okay, let's go over the steps of how to quickly graph an absolute value equation. Because you're not going to sit there each time and plug in a bunch of numbers and figure out what all the different points are going to be. Okay, it's got to be quick. And these are some steps that you just have to memorize. So step 1 is to find and plot the vertex. Remember, a number added or subtracted on the inside changes the x, and it's opposite of what you think. A number added or subtracted on the outside is going to change the y coordinate. If we have a number multiplied in front, that's going to be the slope. Okay, and that's specifically the slope of the right side of the v. Okay, from there, we would just create a mirror image for the other side. So example 1, okay, we have y equals -3 times the absolute value of x minus 4 plus 2. So first we're going to figure out our new vertex. On the inside, that -4, remember on the inside it's opposite, that's telling us it's going to go 4 to the right. And that plus 2, remember on the outside it's normal, does what we think it's going to do. That's going to go 2 up. So the new vertex, and you might want to write this down sometimes when you do these questions until you get the hang of this, our new vertex is going to be 4, 2. And that's the first point we're going to plot. So on our graph, we go 4, 2, and we put it up. Now our number out front is a -3. And I'm going to call it the m. Okay, it's not quite the m, but that's what we're used to. So the slope is -3. And with slope, I do like a rise over a run. So remember, if it's an integer, I can always stick it over 1. And that's going to tell me that from our vertex, we're going to go down 3 and 1 to the right. So from the vertex, I'm going to go down 3, 1 to the right, and put my new point. Down 3, 1 right. Now notice this only gives us one side of our absolute value function. Okay, I can either do a mirror image, or I can also go down 3 and then go to the left instead. So from the vertex, go down 3 and 1 left. Down 3, 1 left, and so forth. And that is how you quickly graph an absolute value function. Now I can also give you a graph, and you have to write an equation. So the first step is still going to be to figure out the new vertex, and that's going to tell you, hey, maybe there's something added or subtracted on the inside of the absolute value, and then added and subtracted on the outside of the absolute value. And after that, we're going to look to see if the slope was changed, and we're going to stick that number out front. So here, our vertex is -3, -3, -1. So in terms of our equation, okay, I'm going to write this to start. Notice I'm leaving a little space in front because I know this slope changed, so something's going to have to go there. I'm leaving a little space in here for now because it moved left or right. Okay, so now that -3, that -3, that it moved left, okay, remember on the inside it's opposite, so that really would have had to be a +3. since it then moved down 1, remember on the outside it's normal, we would have subtracted 1. And then finally, we need to find another good point to help us out. I see another good point right here. Okay, so from there, we would have gone up 1, 2, 3, 4, and over 1. So that would be 4 over 1, or just 4. And this is our absolute value equation. So let's do some more examples together. If at some point you feel like you're good and you want to pause the video and try some on your own and then check to see how you did, that's totally fine. If you're still a little confused and you want to walk through them all together, that's okay too. We'll do more examples in class. Okay, so looking at 1 through 6. Okay, some of these are going to start off not too bad, and then they'll get maybe a little bit more crazy. Okay, so here we have absolute value of x minus 3. That minus 3 is on the inside. So if you want to write yourself some words to help you, if you want to jump right into the vertex to help you, that's fine too. But I'm just going to say that that minus 3 is telling us to go right 3 spaces. So from the origin, our new vertex is going to be 3, 0. There's nothing added or subtracted at the end, so no up and down. There's no new slope out front, so that's your typical up 1, 1 right. And then up 1, 1 left. Then you connect all the way through the coordinate plane, and you're good to go. Number 2, nothing added on the inside, nothing added or subtracted on the outside. That's starting at the origin. But now that negative 2, it's kind of like our slope. We can say negative 2 over 1. So that's saying down 2, 1 right. So from the origin, down 2, 1 right. Down 2, 1 right. Okay, I could also go down 2, 1 left to get the other side. Notice it's a little bit skinnier than our typical V shape, but still a V shape. Number 3, we have the absolute value of x, and on the outside plus 2. On the outside, that's telling us up or down, so this is raising it up 2 spaces. If I wanted to write down what my vertex would be, it would be 0, 2. Okay, nothing out front, so that's up 1 over 1, up 1 over 1. And you can kind of see how quick these can be once you get down these rules. Number 4. Okay, now we're going to have 2 things changing in our vertex. The absolute value of x minus 1 plus 3. On the inside, that minus 1, remember inside is opposite, that's telling us to go 1 right. That plus 3 is telling us to go 3 up. So our new vertex is 1, 3. And our equation, our function, is starting right there. Nothing out front, so up 1 over 1. Connect and you're done. Number 5. On the inside, we have a plus 4. That's telling us to go 4 to the left. Nothing added or subtracted at the end, so our vertex is negative 4, 0. From there, okay, running out of room, I'm going to do up here. The slope is 1/2, so that's going to tell us to go up 1 and 2 to the right. So from our vertex, up 1, 2 right, and you keep going. Notice this one's pretty wide. Now on this side, we can't go too far. And we have our shape. Number 6, nothing added or subtracted on the inside, plus 6 at the end. That's telling us to go 6 up. So the new vertex would be 0, 6, which is right there. That negative now, okay, is telling us to just go the opposite direction. It's going to be flipped upside down. If you need to think of it as negative 1 over 1 to help you, go for that. So down 1, 1 right. Oops, a little off there, but you get the idea. And with these, hopefully we remember our domain and range. Okay, on a quiz or test, what I'll probably do is ask you to graph it, tell me what the vertex is, and tell me what the domain and range is. Okay, for pretty much all of these, your x, your domain, okay, it's going on and on this way, on and on that way, on and on this way, on and on that way. So your domain for all of these will be all real numbers. Now your range would vary based on the question. In this one, okay, your y's are 0 and up, so we would say y is greater than or equal to 0. I'm going to jump to number 3. Okay, here it starts at 2 and goes up, so our y is greater than or equal to 2. Number 6 is a little bit different. I'm going to do this one. Okay, number 6, this is the maximum it could be, so it'll be y is less than or equal to 6. So please don't forget your domain and range, because I can definitely ask you to explain those on these graphs. Flipping over to the back side, we have 3 more graphing. Okay, once again, a little bit more complicated now. Okay, but nothing we can't handle. Number 7 is y equals 3 times the absolute value of x plus 4 minus 6. That plus 4 on the inside is telling you to go 4 left. That minus 6 is telling you to go 6 down. So our new vertex is going to be negative 4, negative 6. So 1, 2, 3, 4, or down there. Our slope is 3. So I can say 3 over 1. And that's going to tell me to go 3 up and 1 right. So from here, 1, 2, 3, 1 over 1. And keep going. We get one side. Okay, now I can go 3 up and 1 left. And I can get the other side of my graph. Number 8. Nothing on the inside, but that minus 3 is telling us to go 3 down. So I'm starting at 0, negative 3. That negative 1/4, remember stick that negative with the top number usually, because that's going to tell you to go down 1 and 4 to the right. And this one I think we can only do 3 points. Okay, and a very fat V. And number 9, number on the inside, opposite of what we think, that's 1 left. Number on the outside, that's normal, so that's 4 up. So we're starting at negative 1, 4. That slope is negative 2, so I can go down 2, 1 right. And then do the other side as well. And that's how you quickly graph absolute value functions. Moving on to writing equations. Remember, our first step is going to be to determine the vertex. Okay, and we're going to plug those numbers in. And then if the slope changed, we got to put a number out front. Okay, so number 10, the vertex shifted down 4. So that means we have that minus 4 out at the end. I'm going to put my y equals. Okay, nothing left or right in terms of the vertex, so that means nothing was added or subtracted on the inside. And here it's going up 1 over 1, so nothing needs to go out front. So it's just y equals the absolute value of x minus 4. So just take it piece by piece and fill the parts in. Number 11, we know it's going to start with y equals. If you put f of x also, that's fine too. Okay, but I think most of us prefer y equals. Here our vertex just shifted over 2. In the x, okay, that means something happened on the inside, and it's opposite of what we think. So if it went 2 to the right, that really means it was a minus 2 on the inside. Nothing out here. Okay, but the slope definitely changed. So I have a point at the vertex, another point right there. This is what happens when you have a tablet sometimes. And from there we can see that the slope was 3 over 1, which is just 3. Number 12, vertex changed a lot here. So the new vertex went 4 to the left and up 1. So I'm going to start with y equals that 4 to the left. Okay, normally we would think negative direction, however on the inside it's opposite of what we think. So that 4 to the left is because it was plus 4. Okay, that 1 up was because of plus 1 at the end. And it looks like it went up 1 and over 1. So no slope out front. So number 12 is y equals the absolute value of x plus 4 plus 1. Number 13, the new vertex is 3, negative 2. So we're going to start with y equals, okay, since it moved 3 to the right, remember it's opposite on the inside, so that's x minus 3. That negative 2, and for the y means it moved it 2 down, so that's normal. And the only thing that happened here is it flipped it upside down. It's still going down 1, 1 right, so all we need to do is throw that negative out front. Number 14, I'm going to scroll down so we get them all in here. Number 14, new vertex is 2, negative 6. Okay, so we're going to start with y equals. Okay, that 2 to the right was because of x minus 2. That 6 down was because of minus 6 at the end. Let's see, another good point for the slope would be right there, which looks like 1, 2, 3, up 5, 1 right. So we need to put a 5 out front. Notice when I'm doing the slope, I keep looking at that right-hand side. Number 15, new vertex is negative 3, negative 4. So y equals that moving to the left 3 is because of x plus 3. Moving it down 4 is because of a minus 4 at the end. And the slope changed, so I'd say that's a good point right there. If you don't see that one, maybe that one up there. But you're going up 2 and 1 to the right. So we throw a 2 out front. Okay, almost done. New vertex is 5, 2. So start with y equals. Okay, in this case, to move it 5 to the right, remember opposite. Oops, that's wrong. Okay, I did not do opposite. So move it 5 to the right would mean it had to be a minus 5 on the inside. To move it up 2 means a plus 2 at the end. And the problem with this one is when we go to do the slope, we don't have, well, maybe it kind of does. It's hard to see, though, that it's that spot right there. Okay, so if you need to go to the other side to help you, that's fine, but just keep in mind, okay, you're not going to use the negative of it, because that would mean it would have flipped upside down. Okay, but in this case, we're going up 1 and 2 to the right, so that should be a 1/2 there. Number 17, new vertex is 2, 4. So start with y equals. Moving it right 2 is because we said minus 2. Moving it up 4 is because it's a plus 4 at the end. New slope. Ooh, where's a good point? Right there is a good point. And it goes down 5 and 1 right, so we need to throw a negative 5 out front. And last one, we're at negative 2, negative 6. Start with y equals. Okay, moving it to the left 2 is because we said x plus 2. Moving it down 6, normal, is that minus 6 at the end. And now, say that's a good point. So we would go up 1 and 3 to the right. So we just throw 1/3 out front. Okay, if you have any questions, please make sure you jot them down. Okay, we'll go over things in class. Okay, and we will definitely practice some more of these.